Hey guys, it's Miss Miklos, and I'm going to be doing a super short review just so that we are totally prepared for our test that is coming up this week. So I'm going to use the review worksheet as a guide, but I'm definitely going to be doing some of our own stuff as well. So I actually want to start with talking about classifying conics, and just so you guys know, the first 5 questions on our test are going to be multiple choice. You guys deciding, is it a parabola, is it a circle, is it an ellipse, is it a hyperbola? So I just want to start by talking about some quick things. Parabola. I know something is a parabola if only x is squared or y is squared. So if we only have one variable that's squared, then I know it's a parabola. For example, if I look at this first problem here, we would say this is a parabola because I only have x being squared. Okay, next thing I want to talk about is a circle. Something is a circle if both x is squared and y is squared. We have addition and they have the same coefficient. So if we look at these next two options, okay, these two options right here, we notice they're both squared. X is squared and y is squared. They both have addition. However, only this second choice down here has the same coefficient because both of those have a coefficient of 1. So we would say that is a circle. Our other option, when they're both squared, we have addition, but they have different coefficients, is when we have an ellipse. And lastly, when they're both squared, but we have subtraction, is when we have a hyperbola. The key thing when we have both x squared and y squared is I want to make sure I get them on the same side of the equation so that it's easy for me to tell what type of conic section it is. Okay, moving on our test, the next, let's see, 1, 2, 3, 4, 5 questions just deal with graphing and finding, or really finding characteristics. Okay, so I want to look at number 5 on the review, part A. It says find the vertex, focus, and directrix of the parabola and sketch its graph. Okay, there is a whole graphing section on the test as well. The ones that you guys are going to be graphing are going to be some equations that you're not going to have to complete the square on. They're going to be in the right form already. So we're just going to have to see how to complete the square from here. Or, I'm sorry, that made no sense. On those problems, I'm not going to have to complete the square. On some of the ones where I'm finding vertex, focus, directrix, different characteristics, I might have to. So for A, is this one that we're going to have to complete the square on? No, because I don't have a y squared and a y. I can tell right away this is a parabola because only one variable is squared. So what I'm going to go ahead and do is I'm going to get y squared by itself. Next thing I'm going to do is divide by 4, so I get x equals 1/4 y squared. We learned that our general formula for a parabola is x minus h equals a times y minus k squared. So in this case, our vertex is 0, 0, because I don't have anything after the h, and I don't have anything, I'm sorry, I don't have an h value, which is after the x. I don't have a k value, which is after the y. Next thing we need to find are the focus and the directrix. And most of you guys did a great job finding the vertex of a parabola. This was the tougher part. The thing we needed to remember was d is equal to 1/4a. Okay, so what this means, the distance from the center, or in this case, the distance from the vertex to the focus or to the directrix is 1/4a. So to find this d value, I'm going to do 1/4 times 1/4, which I end up getting 1. Our focus is always inside the parabola. Our directrix is outside the parabola. So I am going to sketch a graph here. So I'm putting a point at 0, 0 because that was our vertex. Looking at this equation, since it is an x equals parabola, I know the x-axis goes right and left. Since 1/4 is positive, that means that it's going to the right. And the reason why it would be important, even if I was not sketching this, is because that's going to tell me what direction to move for my focus. So my focus now, I'm going to move inside the parabola, because that is where the focus is always inside the parabola, so I'm moving to the right. So I'm going to move 1 to the right. So that gives me an ordered pair of 1, 0. To find the directrix from the vertex, I would move 1 to the left. And that gives me an equation of x equals -1. Okay, so in this case, it was asking me for the vertex, the focus, and the directrix. Definitely stuff I want to make sure I know how to do on our test. Some other ones I want to look at. Okay, this is under number 6. I want to look at B. The reason why I'm choosing this one is because right away I can definitely tell that we need to complete the square. The reason why I can tell is because I have an x squared and an x, and I also have a y squared and a y. So I want to make sure we remember how to do this. First thing I'm going to do, I'm going to determine what type of conic section this is. Since x and y are both squared, they're added, but I have different coefficients, we would say this is an ellipse. So I'm going to go ahead and get my x values together, get my y values together, and I'm going to subtract 141 to get that onto the other side. Now, what might possibly be the toughest part of completing the square is our very first step is always going to be factoring out the leading coefficient. So that means if it doesn't just say 1x squared, I need to factor out that value. So when I take a 4 out, I'm left with x squared plus 4x. When I take 25 out, I'm left with y squared minus, I believe that is 6y, equals -141. Now we can go ahead and complete the squares. So just a reminder, the way I'm always completing the square, I'm taking this middle coefficient and I'm dividing it by 2 and squaring it. So in this case, 4 divided by 2 is 2, 2 squared is 4. Whatever I add to one side, I know I need to add to the other side. However, even though I wrote 4, I need to remember it is like 4 times 4, so I actually am going to add 16. Okay, my other one, I'm taking that 6, so -6 divided by 3 squared, and I'm going to go ahead, -6 divided, why am I dividing by 3? Sorry. -6 divided by 2 is -3. My brain is just thinking too quickly here. -3 squared is 9. So what I'm going to have to do here, I'm going to have to do 25 times 9, and that is what I'm going to have to add to the other side. So when I do 25 times 9, that becomes 225. So I'm going to go ahead and put that on the right side of the equation. So now when I factor this, I'm going to get 4 times x plus 2 squared. The shortcut is that this number 2 is always half of this middle term. So plus 25y minus 3 squared equals, and when I add these all together, okay, give me 1 second while I do the math here since I am working through this for the first time right now also. If I can get my calculator to start working. Okay, here we go. So 225 plus 16 minus 141. I end up getting 100, which is a nice number. Okay, this is not yet in the correct form for an ellipse. For ellipses and hyperbolas, we always need them to be equal to 1. So I'm going to divide everything by 100. I get x plus 2 squared over 25 plus y minus 3 squared over 4 is equal to 1. So I'm not even going to go through every single characteristic of this ellipse. I'm going to go through the ones that I'm going to make you find on the test just to save us a little time. The first thing we need to find is the center. Our center is always HK, which is the opposite of those x and y values. So our center is going to be -2, 3. If we were graphing this, this denominator of x is telling me how far out I'm moving in the x direction, and the denominator of y is telling me how far I'm moving in the y direction. So I am always going to square root that value. So in this case, I'm going to move to the left 2 and up 3. I'm going to erase some of my work here just to help me with my graph. So negative 2, up 3. I'm going to move out 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then up 2 and down 2. Okay, so this is what my ellipse would actually look like. Now, our vertices for our ellipse are always how far we went out in the bigger direction. So in this case, since x has the bigger denominator, those are the vertices. If y had been the bigger denominator, those would have been the vertices. So our vertices here are going to be 3, 3, and let's see, we went negative 7, 3. And we can look at our graph, we can actually figure out what that specific ordered pair is in order to write them down. The final thing I want to make sure that we understand how to do is find the foci. The way that we find the foci for an ellipse is going to be c squared is equal to a squared minus b squared. I'm always going to take the bigger denominator minus the smaller denominator. So in this case, I would do c squared equals 25 minus 4. C squared would be 21. C is going to be whatever the square root of 21 is. Okay, so that would be approximately, let me go ahead and do that on my calculator. I'm waiting for it to load. As I'm waiting for this value, remember that the foci are always in the same direction as the major axis. Okay, so this ends up being like 4.6. So that means I'm moving 1, 2, 3, 4.6 to the right and 4.6 to the left. So when I'm actually figuring out those values, okay, I have 2.63, and then I also have negative so we said we are moving 4.6. So I would have negative 6.6, positive 3 also. Okay, I didn't go through finding eccentricity on the test. You will be okay if you don't know how to find that value. This really would be the important stuff to figure out. For a circle, I would make sure that I know how to find the center and how to find the radius. With a hyperbola, the good news is there's not going to be a question with hyperbolas that make us figure out how to actually find characteristics. I maybe just want to go through a hyperbola problem pretty quickly to review how to graph it. Okay, so this is down, this was number 9, I'm looking at B. Okay, my center is 0, 0, 0. The first 0 comes from the x squared because it's like x minus 0 squared. My second 0 comes from the y squared. So that is going to be my center. Just like an ellipse, this is telling me to go out 2 in the x direction and 1 in the y direction. So I'm going to go ahead and draw out that rectangle. The whole purpose of the rectangle is to help us find what the asymptotes are, and that's really going to help us determine the width of our hyperbola. We learned a hyperbola is really just two parabolas, so what I need to look for is which variable is positive. In this case, y squared is positive. I know the y-axis goes up and down, so that means my parabolas are going to go up and down. Okay, so after the characteristics section, there are 7 problems where you are just matching what the graph looks like with the particular equation. The types of equations you guys would see are the ones where I'm not needing to complete the square, so something like we just went through would be a good example of that. The final 3 questions with conics deal with writing equations based on certain characteristics that are given to us. So since we're working with hyperbola right now, let's go ahead and go through that. Okay, with a hyperbola, okay, it'll be something similar to number 11. The first thing I want to find is our center. This center is going to be the midpoint of these two values. So if I add these together, 2 plus 2 divided by 2 is 2. 3 plus negative 3 divided by 2 is 0. So my center is 2, 0. Okay, what that helps me with right away, I know that I can write x minus 2 squared over something and y squared over something is equal to 1. Since this happens to be a hyperbola, we still need to figure out which one's going to be positive, which one's going to be negative. And the way that we can do that, okay, my vertices were at 2, 3 and 2, negative 3. And I want to look and see what direction did we move in. Did we move the x direction right and left, or did we move up and down? And that would be the y direction. And we can see here we moved up and down. So what I'm actually going to do here is I'm going to switch the order of these and make it y squared minus x squared. If it had been going right and left, then I know that the x squared would be positive. Okay, since it's moving up and down, the vertices are actually going to tell me that denominator, because I know that our center was 2, 0. So we can physically count that we moved 3. So that gives us a denominator of 9, because 3 squared is 9. To find the other thing, what I need to do is figure out what C is. How far am I moving from the center to the foci? If the center's at 2, 0 and the foci is at 2, 5, I'm moving 5. Okay, our formula for this is c squared equals a squared plus b squared. Notice in a hyperbola where we have a minus in the equation, the way we find foci has a plus in it. When we're dealing with an ellipse which has a plus, the way we find the foci is going to be with a minus. So in this case, I have 5 squared equals 9 plus b squared. And it doesn't matter if I use 9 for a squared or b squared. Okay, when I square that, I end up getting 16 is b squared, so 4 is our b value. But I don't even need to figure that out because what is the important part is b squared. So I'm going to put 16 down in the denominator, so that would be our equation. Okay, next one I want to go through here is an ellipse. Okay, it tells us the foci and major axis length. Once again, the center is going to be the midpoint of 2, 0, negative 2, 0, and that is 0, 0. Now, I'm just going to sketch this real quickly. 2, 0 means I'm going to the right 2. Negative 2, 0 means I'm going to the left 2. Since this is a hyperbola, since this is an ellipse, and I know it's an ellipse in the problem, it would tell me that this is an ellipse. I kind of skipped over those directions. We know that the foci are in the same direction as the major axis length. So this length of 10 tells me that I'm really going out 5 in each direction, so that it gives me a length of 10 altogether. Now what that helps me with, okay, I know it's going to be x squared plus y squared is equal to 1. The reason why it's x squared and y squared is because the center is 0, 0. This length of 10 tells me I'm going 5 to the right and 5 to the left. Since that is going right and left, that would make my denominator for x squared 25 because I'm taking 5 and I'm squaring it. I'm going to use c squared equals a squared minus b squared. We can see that the foci are 2 away. So 2 squared equals 25 minus b squared. So I get 4 equals 25 minus b squared. I end up getting that 21 is b squared. So I'm going to go ahead and put 21 as my denominator. And this would end up being our equation. Okay, final conics section problem I want to go through here. I know I'm kind of skipping all over the place a little bit. Okay, I want to find the standard form of the equation of the parabola with a vertex at the origin and a focus at 4, 0. So I'm going to start by just graphing those 2 points. And what that tells me, I know the focus is always inside the parabola. So that tells me that it's going to the right. So this is going to be an x minus h equals a times y minus k squared parabola. I would not have known that it was going to the right, except that they gave us what the focus is. The other thing I know is that a has to be positive. Okay, since our center is 0, 0, I can just skip and say x equals y squared. The only other thing I need to find is a. We learned the equation d equals 1 over 4a. This time I can actually see this distance is 4. So I can say 4 equals 1 over 4a. So 16a equals 1. So a is 1/16. So I'm going to go ahead and put in 1/16 as my coefficient. So I know I went quickly, I kind of skipped around, but this is the type of stuff I would expect you guys to know how to do for conic sections. Definitely review the homework assignments we went through. 20 of the questions on the test do deal with conic sections. Now transitioning into polar. First thing we learned in polar was changing from polar to rectangular and rectangular to polar. You guys need to have these 4 formulas memorized. Y equals r sine theta, x equals r cosine theta, x squared plus y squared equals r squared, and tan inverse of y of x is equal to theta. Okay, these 4 will be on the test. They will be multiple choice type problems. So I'm just going to do a few. Remember, changing from polar to rectangular means I want to get rid of r and theta. I want to get it in terms of x and y. So if I have something like r equals 14, first of all, we've learned that means it's a circle. So it would make sense when I see it in rectangular, it should be x squared and y squared. I don't really have an equation that we can use that just says r, but I do have one that is r squared. So I'm going to go ahead and square both sides, and I get r squared equals 196. At that point, I know r squared is equal to x squared plus y squared, so I'm going to write x squared plus y squared equals 196. Okay, definitely look through our notes, but that's kind of the main thing that we would do there to change things from polar to rectangular. Changing from rectangular to polar, I'm going to choose to go through number 7 here. Number 7 says x is equal to 5. So when I'm changing from rectangular to polar, I want to get rid of x and y and get it in terms of r and theta. I know x is equal to r cosine theta. So this is going to be r cosine theta equals 5. This might be an option on the test. The other option might have been if we actually solved for r. If I solved for r, I would divide both sides by cosine. So I would end up getting 5 secant theta. Okay, one of those would be an option on the test. I wouldn't be tricky and try and mix and match or put them both on there or anything. Okay, next section on the test is going to be like this. This is like the quiz that we took. In fact, there's going to be 4 questions, really similar to what you guys are seeing here on the review. So I'm choosing the letter of the correct point. So if I had something like 3, 7 pi over 12, I know a lot of you guys liked changing it into degrees. So remember to change something into degrees, I'd multiply by 180 over pi. So this would end up becoming, let's see, let me do this math real quickly here. This is what happens when I'm doing this late at night. My brain is going dead. Okay, so I really need to do 15 times 7 So I end up getting 105 degrees. So we know each line is worth 15 degrees, so I'm going to go out 1, 2, 3. Okay, I'm going to go 90, and then 15 more degrees would be 105, so that would be point E. Key thing to remember, positive angles we go counterclockwise, negative angles we go clockwise. I can always make something positive by adding 360 onto it. If we have a negative radius, we start by going to the left. Next section on the test. There are 6 different questions that just deal with you saying, is it a lemniscate? Is it an inner loop? Is it a circle? Is it a rose? Is it a line? Is it a cardioid? Is it dimpled? We spent a lot of time in class going through that, so I'm not going to go through ones just like that. But we'll kind of do this when we're sketching the graphs as well. Okay, then there's a matching section where there is an equation and then we need to sketch the graph. So if we had something like r equals 3.14, I know when I just have r equals, that would be a circle. So that's telling me to go out 3.14, so 1, 2, 3. It's just past that third circle, and I would go all the way around. Okay, if we go to one like number 15, r cosine theta. R cosine theta we learned is equal to x. Okay, this was like the quiz that we took in class today, our survivor quiz. We saw stuff like this. This would be a line, and x equals 4 means I'm going to the right, 1, 2, 3, 4, and I'm going to draw a vertical line. Now number 16 looks pretty similar. In fact, some of you guys might think it's a rose. However, we have an in value that's equal to 1. So that tells me that it is a circle. Okay, we said cosine goes with x, sine goes with y. So since this has a positive 4, that means I'm going to go to the right 1, 2, 3, 4, and I'm going to draw a circle connecting 4, 0 with what we call the pole. And that's like the origin of our polar graph. If it said negative 4 cosine theta, it would be on the left side. If it was sine, it would be up top on the y-axis. If it was negative sine, it would be down below. Okay, 17. 17, looking at that, we would say that is a rose. Remember, our rose forms was a sine in theta, and r equals a cosine in theta. So some things for us to know. N equals 4, so we have 8 petals. Okay, remember if n is even, I'm doubling it. If n is odd, then I'm leaving it exactly the same. Since it is cosine, I'm starting at 0 degrees. If it was sine, I would have to do 90 divided by n to figure out where our first petal is. Our A value, which in this case is 1, is going to tell me how far out our petals are. Final thing, to figure out the distance between petals, okay, I'm going to do 360 divided by the number of petals. So in this case, I end up getting 45 degrees. Okay, so I'm really going to zoom in here. So my first petal is at 0. Then I'm going to go 15, 30, 45, 15, 30, 45, 15, 30, 45, 15, 30, 45, 15, 30, 45, 45. And I'm going to go ahead and graph all of those petals out. The only difference if this had been sine, okay, our first petal would not have been 0. We would have done 90 divided by 4. And our first petal would have been at 22.5 degrees. Okay, now remember, you guys aren't graphing this by hand. It is a matching section, so you guys will be in good shape. Okay, one like 18. The big difference with 18 is that I have this plus sign. That tells me right away this is a limestone. Okay, we had 3 different types of limestones. In this case, my A value is 4, my B value is 1. The absolute value of 4 is bigger than 1, so this became dimpled. Remember, if they were equal, it was a cardioid. If B was bigger than A, then it was an inner loop. So this is when we made an R theta chart, and the 4 ordered pairs I'm using are going to be all of our quadrantal values. And I would definitely go ahead, and if you feel more comfortable using a calculator on this, I would. Okay, I'm going to do this kind of quick. When I substitute 0 in for cosine, I know cosine of 0 degrees is 1. So 4 plus 1 is 5. So I'm going to go ahead and plot a point at 1, 2, 3, 4, 5. When I put in cosine of 90 degrees, I get 0. So then I would have to do 4 plus 0, which is 4. At 180, cosine of 180 is negative 1, so 4 minus 1 is 3. And lastly, cosine of 270 is also 0, so 4 plus 0 is 4. Okay, so I'm going to go ahead and graph that. Notice it is symmetric on the x-axis. We said x and cosine go together, so that would make sense. Okay, so we have dimpled, we have a cardioid. At a cardioid, remember one of the points is at 0, and then we have the inner loop, okay, which would be like something like this. The nice thing is you guys aren't graphing it by hand, you are looking to see, so it would be pretty obvious. Okay, I'm going to skip to 21 here. Actually, let's skip to 23. As soon as I see this r squared, I know that it is a lemniscate. Okay, sine, we said, is either at 45 degrees or negative 45 degrees. Since it's a negative 16, my first petal is at negative 45. If it's cosine, it's either at 0 or at 90. Okay, so what I'm going to do the square root of 16, and that tells me that we're going out 4. So I'm going to go to the right, 1, 2, 3, 4, and go negative 45 degrees. And I'm also going to go to the left, 1, 2, 3, 4, and go negative 45 degrees. So this should look like a bow tie. So that would be our answer. Okay, so that's a pretty quick idea in what graphing looks like. The final thing, and just so you guys know, there are only 3 of these on the test, is finding a polar equation for each of the following graphs. Why don't we do a lemniscate, a rose, and a limacone? So let's look at C. First of all, I can tell this is a rose. Second thing, since I have the first petal here at 0 degrees, I know that it has to be r equals something cosine something theta. Okay, we can tell it goes out 1, 2, 3, 4, 5, so it is going to be 5 cosine theta. And let's count how many petals we have. We have 1, 2, 3, 4, 5, 6, 7, 8. Since 8 is an even number, I need to divide it by 4. So that gives me an equation of r equals 5 cosine 4 theta. Okay, if we look at D, I can definitely tell that D is a limacone. And in fact, I can tell that D is a limacone that is symmetric on the y-axis. So that tells me that it is going to be something plus something sine theta. And this is when we chose different ordered pairs. So in this case, okay, I'm going to use 2 0 degrees. And this one here can be kind of tough because when I go up top, I don't see anything. So that tells me I must have a negative value. So I'm going to go to the one that's closest and use negative 290 degrees. Now, if you really wanted to argue, you could state a case that you could use this ordered pair as well. I normally use the one that's closest to the origin. The one on the test will not be confusing like this. There will only be one way to do it, so you'll be okay. So I'm going to say 2 equals a plus b sine of 0. I'm also going to have negative 2 equals a plus b sine of 90. Now I know sine of 0 is 0, so I get 2 is equal to a. Sine of 90 degrees is 1, so I get negative 2 equals a plus b. So I'm going to go ahead and substitute 2 in for A. So I have negative 2 equals 2 plus B. Negative 4 is B. So my equation is going to be R equals 2. And instead of plus, I'm going to write minus 4 sine theta. Now a good check, since it was an inner loop, the absolute value of the B value should be bigger than the absolute value of the A, and in this case that is true. Okay, final one I want to go through. E, we can tell that's a lemniscate because it is impossible for a rose to have 2 petals. Because if the n value was 1, it would be a circle. If the n value was 2, we'd have to double it and it would have 4 petals. So I can tell this is a lemniscate. The other thing I can tell is that this has to be sine. So it's sine 2 theta because it is not at 0 degrees or 90 degrees. Since the first petal is at 45, I know it's going to be positive sine. And it looks like we're going out 1, 2, 3, 4. So I'm going to write r squared equals 16 sine 2 theta. Okay, so overall there's 45 questions on our test. Some of them are going to take a little bit longer than others. Ones you definitely should all get correct is knowing how to classify. Those should be easy points. Spend time studying that. The rest of this gave a really brief outline on what to do. You guys have lots of material that you can study if you need additional practice. And I am in my room at lunch on Wednesday if you need additional help. Okay, so that's about it. Good luck studying, and I hope everybody does great on this test. Bye.